Welcome back, everybody. So we're in video part 2 here, so we're going to be jumping around a little bit, and I'll leave some of the exercises here for you to do on your own. But continuing on with our multiplication examples, we'll note from last time we did a couple of examples here, so I think we'll do one more. We'll look at number 3. So this one we're going to have to, again, start by factoring. And what we'll note is that x cubed minus 27 is what we call a difference of cubes. So if we have something that looks like x cubed minus a cubed, that is going to factor in a very particular way. So the binomial expression that we start with is simply going to be the uncubed terms. So it'll just be x minus a. And then we're going to multiply that by a trinomial that is composed of the squares of our terms, so x squared and a squared. And then in the middle, it will be the product of the two, so a times x. And there's a nice little mnemonic we can use to remember the factoring operations. So the binomial will have the same sign as our original difference. The first operation between x squared and ax is going to be the opposite of what the original expression is, which is a difference. And then this last term is always positive. So you can remember the mnemonic SOAP, same opposite, always positive, for how these factor. So that means here we'll just notice that we have 3 cubed, so 27 is 3 cubed. So then this is going to factor as x minus 3 times x squared plus 3x plus 9. And then we're going to multiply that by x squared minus 4, which is going to factor as x minus 2 times x plus 2. And all of that is going to be over x plus 4 times our quadratic here, which we can factor as x minus 3 and x minus 2. Again, we'll note our undefined values. So our undefined values are going to be negative 4, 3, and 2. And then we can go ahead and cancel out anything that is a common factor in the numerator and denominator. Looks like that's it. This term that is inside of the difference of cubes will never be a factorable quadratic. So the solutions to that expression, if we think of it as a function, are going to be irrational numbers or complex numbers. So we're just left with x plus 2 times x squared plus 3x plus 9 all over x plus 4. And note, we don't need to multiply the expression out. Leave it in factored form if possible. We would only really multiply it out if that was going to be useful to simplifying the expression further. But since we've already have it written in factored form, we don't need to worry about that. So I'll let you do number 4 on your own, but I'll just add a secondary note on cubes that we also have a factoring for the sum of cubes. So that's going to look like x cubed plus a cubed. And that factoring is going to look very similar to the difference. So we're still going to have a binomial and trinomial. And we're still going to use that same opposite, always positive operation. So we'll have x plus a instead of x minus a. And then we're still going to have x squared, a times x, and a squared. But now the opposite sign is going to be subtraction. And again, this last term is always positive. So same opposite, always positive still applies. But now our signs have changed because we have a sum instead of a difference. So these are 2 factoring techniques that you're going to want to review because they will pop up from time to time. And just to add a note there, if we have a sum of quadratics, this is not factorable. So the sum does not work for quadratics. So this will represent a complex number, not a real number, which is what this will be. So again, this will always have a real root to it, as long as a is a real number. All right, so jumping down here, now we're going to look at division. Division is going to be a bit more complicated because when we divide a fraction by a fraction, so let's say like 3/5 divided by 7/8, we can think of this as multiplication by multiplying by the reciprocal. And it's really actually going to be useful for us to kind of use that old division notation that you may have become unaccustomed to because we use fractions so often. That can help you kind of line up the expression a little bit better. So you can use this expression on the left where you write a rational over a rational. We call this a complex fraction. Or you can use that old school division notation, which I have put here in our examples. So again, we're going to jump around a bit. So we're going to skip number 1. I'll let you do that one on your own. But we're going to look at number 2. So if we look at number 2, we'll start by, of course, factoring everything. So we won't even worry about reciprocating for the moment. So what we'll note is we've got an x squared that we can factor out of that first x to the 4th minus 9x squared, which is going to leave us with x squared minus 9. And that's all over x minus 3 times x minus 1, it looks like. And we're going to be dividing that by, well, again, we can factor out an x squared. And then we'll have x squared plus 2x minus 8 all over x minus 4 times x plus 4. So we're going to be doing a little bit more factorizations here, obviously. So let's kind of write it out fully here. So we can factor the difference of squares there. We're still going to leave it as division. We're going to have x squared, x plus 4, x minus 2, and then x minus 4 times x plus 4. All right, so at this point, now we're going to write our undefined terms, and we're going to have to be a little bit extra careful here. So note, we are definitely going to look at the denominators. So if I look at my given denominators, we can see that 3, 1, and then plus or minus 4 are all going to be undefined. But I'm also dividing by this whole thing, meaning that now the zeros of this divisor are also going to be undefined. So we need to add in a few here. So it looks like we're going to add in 0. Negative 4 we already have accounted for, but then we're going to add 2. So there's actually 6 undefined values. And again, that's because we're dividing by this expression, which means these values equaling 0 is the same as division by 0. We're going to get something undefined. All right, so now that we've got that, now we'll do the reciprocation. So we've got x squared times x minus 3 times x plus 3 all over x minus 3 times x minus 1 times, and now we'll put x minus 4 times x plus 4 all over x squared times x plus 4 times x minus 2. And let's see what cancels. Our x squareds are going to cancel, and x minus 3 cancels, and x plus 4 cancels, and I think that is it. So then our final expression is going to be x minus 4 times x plus 3 in the numerator all over x minus 1 times x minus 2. So again, you can feel more comfortable if you kind of remember how to evaluate these, so you can kind of cut the steps down if you want to, but definitely be really, really careful to remember those additional undefined values in our numerator of that dividing expression. All right, so we'll go ahead and jump down to number 4, since this one's probably the most complicated of the grouping here. So again, we've got multiplication and division going on here. So we're going to need to be extra careful. So we'll go ahead and start by factoring. There's going to be lots of things to factor. So for our first expression, x squared plus 9x plus 20, looks like, let's see, we're going to have x plus 4 times x plus 5. And then we're going to have x plus 2 and x plus 1. And we're multiplying that by x minus 4 times x plus 2 all over. So 9x squared minus 16 is a difference of squares. So 3x minus 4 and 3x plus 4. And then we're dividing by x minus 4 times x plus 4 all over our 3x squared quadratic here, which looks like it's going to be 3x. Let's see, we need 4 and 2 maybe. So plus 2 plus 4 will give us 10 in the middle, I believe. Yes. Okay. All right. So again, before we start, we're going to jump to those undefined values. So x is not going to equal to, of course, anything in our denominators. So all of those values we will exclude. So we've got -2, -1, plus or minus 4/3, and then -2 again, so we don't need to put that twice. But then we're also going to exclude these divided values. So plus or minus 4 are also going to be excluded, since those are going to be division by 0 problems if we let x equal 4 or -4. And so now we can reciprocate and then evaluate. So we'll write out all of our terms here. And that's going to be times x. Don't forget to reciprocate. 3x plus 4 times x plus 2 all over x minus 4 times x plus 4. And now we will start canceling. So let's see, we've got x plus 4s, no x plus 5, x minus 4, x plus 2, 3x plus 4, and I think that is it. So we'll have x plus 5 times x plus 2 all over x plus 1 times 3x minus 4. And that is our final expression with these excluded values. So again, 1 and 3 I'll leave for you to do on your own. You can check the completed notes online, but definitely very similar processes. All right, so our next expressions are going to be equations that we want to solve. So again, we're going to kind of jump around a bit, but we will definitely keep track of our undefined values. So again, I think we'll look at the even examples here. So for number 2, what we'll note first is that x cannot equal 3 over 2. So again, if we end up with an answer of x equals 3 over 2, we would say that this is an extraneous solution, which means it is not in the domain. All right, so let's go ahead and factor here. You don't have to factor. You can multiply both sides by 2x minus 3 if you want to, but I'm going to highly, highly recommend factoring. So I think let's assume that this is going to cancel and see if we can get a factorization that works. That means that that would be 5, and we would need that to be plus. So you can check to see that that works. So again, if we have a single expression here, most likely it's going to be a factor. Not necessarily always, but that would kind of be the starting point. If the factorization is not obvious, keep in mind though, for all these quadratics, you can still use the quadratic formula. It's a little bit longer, but you can use the quadratic formula, so don't be afraid to do that if you struggle a little bit with factoring. So those are going to cancel, and we'll end up with x plus 5 is equal to 10. So we'll get x is equal to 5, and that is our solution, which of course is not an extraneous solution. So you shouldn't end up with any extraneous if you do the factoring and canceling ahead of time. So for number 4, I'm going to take a slightly different approach. Again, we could factor this and then cancel terms, but I'm actually going to do that multiplication step instead, just to show you what that looks like. So I'm going to multiply both sides of my equation by my denominator. And what we'll note here is that this is actually going to factor pretty nicely. So we'll have x plus 6 and then x minus 2. And we can also note that the numerator is going to be x times 2 minus x. So kind of getting that work out of the way. But I'm going to multiply through by our denominator here. So the denominator will cancel on the left, but it will be multiplied by 1 on the right. And actually, before going on, let's just note here what's undefined. So -6 and 2 cannot be solutions. So what we're going to end up with after multiplying both sides is 2x minus x squared equals x squared plus 4x minus 12. And then we're going to combine all the like terms. So I'll subtract the 2x over, which will give me 6x. And then I'll add the x squared over, which is going to give me 2x squared minus 12. So then we can divide everything by 2. So we'll get x squared plus 3x minus 6. And now we can try and factor this to see if it'll factor. Oops, and I think I did this incorrectly. Let's go back, because that doesn't work. And so what I should have done is been a little bit more careful. So let's do this a little bit more carefully. So we're going to add those in much more carefully. So this will become 0, this will become 0, and then we'll have 2x squared plus 2x minus 12, which we can then divide by 2. So definitely be careful with your algebra and double check your work. So we're going to end up with x squared plus x minus 6, which does work. And so that is going to be x plus 3 times x minus 2. But this would mean that x equals -3 or x equals 2. But because we have an undefined value at 2, this is extraneous, meaning this is our only solution. So what you'll notice here is, first, that I made a mistake, so definitely be careful with your algebra. And second, that this is kind of a bit more work than we probably needed. So looking at the previous example, that factoring is much, much nicer in terms of simplifying very quickly, whereas this is going to require a bit more work. So again, I'm going to recommend factoring always as opposed to multiplying both sides by the denominator, especially when the expressions get a lot more complicated. But this method will work, but you do have to be very careful of extraneous solutions that you will have to edit out by looking at the undefined values. So 1 and 3, again, you can do on your own and check the notes online. And so what we're going to look at next is complex fractions. So now we're going to have fractions over fractions. So rational expressions divided by other rational expressions. And for these, it's really going to be the same approach, because if you think about it, this is really just the same as x plus 1 over x plus 3, if we use the first example, divided by x squared minus 9 over x squared minus 3x plus 2. So really, complex fractions are just different notation for this division that we did earlier. So my recommendation is rewrite it as a division unless you feel really comfortable with working with the rational expressions. So maybe we'll kind of do it both ways. So we'll see what each one looks like if we keep it in the rational expression form or move it to the division notation form. So the one thing that does not change is finding our undefined values. So what we'll note is we can factor our divisor here. So we've got x minus 3 times x plus 3 in the numerator, all over x minus 2 times x minus 1. So if we were looking at the rational expression version of this, we would get, oops, the same expression, but again, just written in that fractional form. And again, our undefined in the dividing form is going to be all of those denominator values. So maybe we will make some room and put this above to save ourselves a bit of space. So we'll have x not equal to -3, 2, and 1. But then we also exclude x minus 3 and x plus 3. So that is going to be, adding 3 on, we already have -3 represented. If we were looking at the complex fraction version of it, essentially all of this and this are excluded. So we look at everything except for the very top numerator. So none of those factored values can equal 0. All right, so then working on the right-hand side here, we would get x plus 1 over x plus 3 times x minus 2 times x minus 1, all over x minus 3 times x plus 3. And what we'll see here is, well, are we going to get any cancellation? And let's see. So we get nothing that cancels, it looks like. So we're just going to end up with that as our final expression. Let's double check that with our rational expression. So we'll have x plus 1 over x plus 3, and then I'm going to write this as times, and then just reciprocate. So again, we'll just kind of do the same thing we did on the right-hand side, and so you would just reciprocate that whole expression and make it into a multiplication. And what we'll see is nothing cancels. So we end up with that as actually being our simplified expression, but now we have it as a single rational expression. So our goal is just to get rid of this middle division. We just don't want that. We just want an expression divided by another expression. So that is it. Or a polynomial, I should say, divided by a polynomial. All right, so you can try number 2 on your own. I think I will give number 4 a try here. So now we've got 2 expressions, and our denominator is kind of in a different form because we've got this 1/3 coefficient here. So what can be useful here to start is to find a common denominator if we have any terms that are not fully rational in how they're written. So we'll multiply x by 3 over 3, so we'll get 3x plus x all over 3, which is going to be 4x over 3. You could have also just added 1 and 1/3, obviously. And then from here, we can see that we're going to write this as x over x plus 1 times 3 over 4x. We should note our undefines, so we're not going to equal, well, if we look at this denominator, -1 is undefined. And then here, this just can't equal 0, and that would be true when x is equal to 0. So it looks like -1 and 0 are only undefined values. And then we can just do a little cancellation here. So we'll end up with 3 over 4, oops, times x plus 1. So again, 2 and 3 you can do on your own and check those completed notes online. And then our last step is going to be adding and subtracting. I think we'll stop here and we'll add a part 3 to focus on adding and subtracting, because these are going to be examples where we need to be really careful. So we'll pause here, come back for the third video. So until I see you next time,